A rectangle, a rectangular storage area is to be constructed alongside of a building. Right here, we're putting a storage area alongside of a building. A security fence is required along the remaining three sides of the area. We want to maximize the area that can be enclosed with 920 foot of fencing. So we have 920 foot of fencing. We could make it, long and narrow or short and wide or somewhere in between. How should we make the rectangle using all 920 foot of fencing to get the maximum area? Well, um, down here it says the side parallel to the building we'll call X. It's this side, it's parallel to the building. And the side perpendicular to the building we'll call Y. So these sides are Y. And then we found an area formula in terms of X only. Now that we did that in another part, another question. That was the setup. Now we're going to finish it up. So we got that area formula. Now, in order to maximize the area of the rectangle, first off, find X. So I'm going to take that area formula, which again was found on another part. I'll take that area formula and I'm going to actually distribute it. So that's going to be 920 over 2. What is that? Use your calculator, 450, 460. 460x, right? 800, yeah, minus a half x squared. I just distributed the x through there. So that's area. Now, how do we maximize? We take the derivative. Don't we? Take the derivative of this. This should be easy. 460, because that 1 just comes down. Subtract 1, it's gone. This 2 comes down, so that's minus 1. Half times 2 is 1. X to the 1, subtract 1 from the power. And we set that equal to 0. Well, that is a dream to solve. Move that over. Positive x is 460. Boom. Sure enough, 460, and that's feet. Everything's in, well, I mean, the lengths are feet here. Okay, next they want us to find, so that's x. This is 460, x, from there to there. Okay, but what's y? Let's see, what is y? Well, how are we going to get y now? How are we going to get y? Well, we're going to have to remember there's 920 feet of fencing, so that means y plus x plus y. Those three have to make, so y plus x plus y have to make 920. That means 2y plus x, and x is 460, has to equal 920. Subtract 460. Boom. 2x is it 460? Coincidentally? All right. And then divide by 2. Wait, I'm solving for y, not x. I'm getting a little confused there. Let's try that again. It's 2y divided by 2. Y is 230. Yep, y is 230. So this side must be 230 and this side 230 feet. Okay, finally, what's the area of the story? What's the total area? Well, you know how to figure out the area of a rectangle. Well, let's come back up here. The area inside this rectangle. Area of a rectangle is always one side times the other, length times width. So we say, okay, well, that's 230 times 460. Doesn't matter what order you put them in. Just multiply that. 230 times 460. Go to Desmos. 230 times 460. That's 105,800. 105,800. That's square feet because area is always squares. It's like how many squares you can fill it up with, right? The area of a rectangle formula. That's always, make sure that's clear. Oh, that was really bad. If I make a rectangle and I make it 3 squares tall and 2 squares wide. You know how many squares are in here? 6, huh? 3, 4, 5, 6. So the area inside is just one side times it. You might say, why don't we use the 230 twice? No, that's for area, we just use the length one. The area is the squares inside, just length once, width once, just multiply those and we get that. So it's square. See how it's actually how many squares? That's why it's square feet. That's why we do that. So that's the dimensions. If you want to make that, if you have a total of 920 feet of fencing left, You should make the rectangle 230 by 460 by 230. That'll use all your 920 feet of fencing, and that'll produce the biggest area. It'll produce 105,800 square feet area, most possible. So it's very practical for, if you're building something to make it as big as possible using that amount of fencing. And so there we go.